So in this video, we're going to go over the questions that are in part 2 of your Unit 1 test review. So part 2 is all about solving logarithmic equations. So we're going to be using all of our equation solving methods, except now our equations are going to have logarithms in them. So let's look at this first equation. So very important when you're solving equations is always check that your logarithm is isolated, right? We want the log to be by itself on one side of our equation. If the log is by itself, then you can go ahead and rewrite in exponential form. Okay, so remember when we draw our arrows, we're going to go ahead and that's going to help us out rewriting in exponential form. So if I rewrite this is going to become 7 to the y is equal to 343. So whenever we have something like this, it's good to check in our powers chart to see if that 343 is a power of 7. You can see here that it is in fact a power of 7. 7 to the third is equal to 343. So we can rewrite this as 7 to the y is equal to 7 to the third. And we know that if these two are equal like that, that means the exponents are equal. So we have y equals 3. Okay, and that's how you'd go about solving this equation. Let's try number 2. So number 2 is a little bit different because notice our logarithm is already not isolated, okay, because it has that -6 in front. That -6 is a coefficient, so we need to go ahead and get rid of that by dividing both sides by -6. So when we divide both sides by -6, we have the log base 5 of x is equal to -24 divided by -6, which is +4. Now that the logarithm is isolated, we can go ahead and rewrite this in exponential form. So this is now telling us that 5 to the fourth is equal to x. Okay, well, when we have 5 to the fourth is equal to x, we can actually use Desmos to help us figure that out. We can just calculate 5 to the fourth, and you can see that's telling us that 625 is equal to x. Now let's try number 3. Okay, so in number 3, once again, you can see my logarithm here, this log base 6 of x minus 10. That's not isolated because I have a -3 right here. So to get rid of this -3, I need to do the opposite, which is going to be to add 3 to both sides. So when I go ahead and add 3 to both sides, that's going to give me the log base 6 of x minus 10 is equal to -1 plus 3, which is 2. Now that my logarithm is isolated, I can go ahead and rewrite this in exponential form. So when I do that, that's going to give me 6 to the 2 is equal to x minus 10. Well, 6 to the 2 power, that's just 6 squared, right? That's 36. 36 equals x minus 10. So now to solve for x, I'm going to go ahead and add 10 to both sides, which gives us 46 is equal to x. So now let's try question 3. So here we have -10 log base 11 of 4x plus 9 equals -20. So here the logarithm is not isolated, so we need to go ahead and first divide both sides by -10. So when you divide both sides by -10, we get the log base 11 of 4x plus 9 is equal to -20 divided by -10, which is 2. So now we're going to go ahead and rewrite this in exponential form. So when we do that, we get 11 to the 2 is equal to 4x plus 9. Well, 11 to the 2, that's 11 squared, so we have 121 equals 4x plus 9. So now that we have 121 equals 4x plus 9, we need to think about how we're going to go about solving for x. So we're going to start off by subtracting 9 from both sides, and when we subtract 9 from both sides, we get 112 equals 4x. So now that we have 112 equals 4x, we're going to go ahead and solve for x by dividing both sides by 4. So when we divide both sides by 4, that's going to give us 28 is equal to x. So now let's try question number 5. So in question 5, once again, you can see the logarithm is not by itself. It has a coefficient of 3, and also we're subtracting 7. So now it's a question of, do we get rid of the 3 or do we get rid of the 7 first? Well, you generally want to do the adding or subtracting before you do the multiply or divide. So I'm going to start off by adding 7 to both sides to start off isolating my logarithm. So I'm going to have 3 log base 3 of 5x plus 8 is equal to 15. So now I need to get rid of that 3, so I'm going to go ahead and divide both sides by 3. And when I do that, I get the log base 3 of 5x plus 8 is equal to 15 divided by 3, which is 5. So now I'm going to go ahead and rewrite this in exponential form. So that's going to give me 3 to the 5th equals 5x plus 8. 3 to the 5th, that is going to be equal to 243. So 243 equals 5x plus 8. And then we're going to go ahead and start off by isolating with subtracting 8 from both sides. So when I subtract 8 from both sides, 243 minus 8 is going to give me 235. So I have 235 equals 5x, and then I'm going to go ahead and divide both sides by 5. When I divide both sides by 5, that's going to give me 47 is equal to x.